So you've got an ESP32, and you've probably heard it's this incredibly powerful little chip. But maybe you're looking at it thinking, okay, where do I even begin? If that sounds familiar, don't worry, you're in exactly the right place. Today, we're going to break it all down. We're going to demystify this thing and show you how to tap into all its power. And the best part? We'll be doing it with the good old familiar Arduino language. All right, let's jump right in. All right, so here's our game plan. First, we're going to cover the absolute fundamentals, the basic structure of any code you'll write. Then we'll get into the fun stuff, sensing and acting, which is all about making your projects actually do things in the real world. From there, we'll dive into the ESP32's biggest claim to fame, going wireless. And to wrap it all up, we'll look at power, performance, and the coder's toolkit that'll help you pull it all together. Sound good? Let's get started. Okay, first up, the basic structure. You know, every single Arduino program, whether it's for a simple Uno or a powerful ESP32, has this fundamental two-part structure. It's like the heartbeat of your code. And once you get this, everything else starts to click into place. So the first part of that structure is a function called setup. Think of it like this. Before you start cooking, what do? You get all your ingredients out, you preheat the oven, you chop your vegetables. That's exactly what setup does. It runs just one time, right when the ESP32 powers on, and its job is to get everything ready for the main show, setting up pins, starting a serial connection, that kind of thing. And if setup is getting your kitchen ready, then the loop function is the actual cooking. This is the part that runs over and over and over again forever, as long as the board has power. This is where the real action is, reading a sensor, blinking an LED, checking for a button press. It just keeps on repeating, and that's what makes your project actually do its thing. So it's really that simple. Step 1, setup runs once at the very beginning. Step 2, loop takes over and just repeats forever. That's the foundation for literally every project you're going to build. Got it? Awesome. Now let's build on that. Okay, so we've got the code structure down. Now it's time to actually interact with the real world. This is where we talk about the input and output pins. I like to think of them as the ESP32's senses and muscles, the way it can see, feel, and affect the world around it. So let's start with digital I/O. This is the simple on or off, yes or no world. You've got 3 core commands here. First, pin mode. That's where you tell a pin what its job is. Hey, pin 13, you're an output, or pin 4, you're an input. Then you have digital write, which is how you send a signal out, like sending a high signal to turn on an LED. And digital read is how you listen in, like checking if a button is being pressed. That's it. These 3 are your bread and butter. But you know, the real world isn't just on or off, right? Sometimes you need to know how much. That's the difference between digital and analog. A digital read is like asking, is the button pressed? It's a simple yes or no. But an analog read is like asking, how bright is the light in this room? You're not looking for a yes/no, you're looking for a value in a range. Think of it like a light switch versus a dimmer knob. Digital read is the switch, analog read is the dimmer. And it works the other way around for outputs too. Digital write just turns an LED on or off, but analog write lets you control its brightness smoothly. So instead of a harsh blink, you can get a nice, gentle fade. It's way more professional looking. All right, let's get to the main event. This is the reason most of us are using an ESP32 in the first place. I'm talking about its superpower, built-in wireless connectivity. This is what truly separates it from something like a basic Arduino. We're about to unlock a whole universe of possibilities by getting our projects online. So when it comes to Wi-Fi, you have a whole toolkit at your disposal. You've got Wi-Fi.begin to connect to your home network. You can check the connection status, get your IP address, or disconnect. And here's a really cool one, Wi-Fi.softAP. This lets you turn the ESP32 itself into a Wi-Fi hotspot. How cool is that? Now that might seem like a lot of commands, but don't get overwhelmed, because honestly, it all starts with just one line of code, Wi-Fi.begin. Seriously, you just give it your network name and password, and boom, your project is on the internet. That one command is your ticket to the entire Internet of Things. Oh, and the wireless party doesn't stop at Wi-Fi. The ESP32 has Bluetooth too. This is awesome for talking directly to your phone or another device without needing a router. Just use serialbt.begin and you can create a simple Bluetooth serial connection. Super versatile. Okay, so we know the basics. We know how to talk to the world, and we know how to get online. Now let's talk about some of the more advanced stuff, the features that really let you get the absolute most out of this chip, both in terms of power and performance.
So let me ask you a question. We've all been here, right? You build this amazing battery-powered project, maybe a weather station for your garden, you're super proud of it, and then the battery dies in a day. Ugh, it's so frustrating. So how do you make a project last for months or even years on a single battery? Well, the answer is a feature called deep sleep. And this isn't just a light nap, this is full-on electronic hibernation. The ESP32 shuts down almost everything using a tiny, tiny fraction of its normal power. You can then tell it to wake up, say every 15 minutes, take a sensor reading, send it over Wi-Fi, and then go right back to sleep. The command is ESP Deep Sleep Start, and it is the absolute key to long battery life. Here's another performance booster. The ESP32 actually has 2 processing cores. It literally has 2 brains. This is a game changer because you can run 2 different tasks at the exact same time. So for example, you could have one core completely dedicated to managing the Wi-Fi connection, making sure it's rock solid, while the other core is busy running your main code, like updating a display or reading sensors. It's like multitasking on steroids for your microcontroller. All right, for our last section, let's open up the Coder's Toolkit. These are the essential building blocks, the data types and commands that you're going to use in pretty much every single project, so it's good to have a handle on them. First up, data types. Think of these like different sized boxes for your information. You've got an int for whole numbers, a float for numbers with decimals, a bool for simple true or false, then you've got string for text and a byte for small numbers from 0 to 255. Choosing the right box is important. You don't want to use a giant box for a tiny item, right? It's the same with code. Using the right data type makes your code more efficient, and on a microcontroller, that really matters. And here are some other tools for your utility belt. Serial communication with serial.print is your best friend for debugging. It's how you get your ESP32 to talk back to your computer. Of course, you have all the standard math functions, but here are 2 cool ones. Timers, which let you schedule tasks with way more precision than just using a delay, and touch pins. Yep, many ESP32 pins are touch-sensitive, so you can create sleek interfaces with touch read. So there you have it. That's the grand tour. We've covered the absolute basic structure of the code, how to sense and act on the world around you, how to unleash its wireless power, and even peeked at some of the more advanced performance features. You've seen all the building blocks. So now the real question is, what are you going to build first?